One of the most common server-side injection attacks is SQL injection. A SQL injection attack allows the attacker to modify the SQL code that is executed by the database server. As you can imagine, this has severe consequences. Examples are the extraction of data, the modification of data, or even the destruction of the entire database. Before we dive into the details of SQL injection, let's investigate an example attack in our BeerSafe application. The search feature enables a user to find a specific beer in the entire catalog. To enable this functionality, the application sends a search string to the server. The server, in turn, queries the list of beers in the database, using the search string as a constraint. The server uses a list of results to create a new page and sends it back to the browser. If implemented incorrectly, such a scenario is vulnerable to a SQL injection attack. Take a look at the flow of such an attack. The attacker uses the same search functionality as before, but now he embeds a piece of malicious SQL code into the search string. The search string is sent to the server, where it becomes part of a SQL query. The server sends a SQL query to the database server, which executes it. But due to the SQL injection vulnerability, the structure of the query has changed. The database server executes the injected SQL code alongside the legitimate query. Let's make the example more concrete with actual code snippets. The injected SQL code is a drop statement. Even if you are not too familiar with SQL, you can see where this is going. This code instructs the database server to delete the entire database. Deleting an entire database using a SQL injection attack seems catastrophic. But the fallout from this attack is not too hard to address with proper backups. Other scenarios are a lot worse. Imagine the attacker stealing all the data in your database, including sensitive user information. What if the attacker modifies the data in the database? Would you be able to detect this? SQL injection is one of the most dangerous problems in web applications. Both the consequences and prevalence of SQL injection vulnerabilities contribute to this status. It should not come as a surprise that injection vulnerabilities rank first in the OWASP top 10. But is it that hard to prevent SQL injection attacks? Based on the attack scenario from before, it seems that banning the semicolon should do the trick. Unfortunately, it's not that easy. Appending a query with a semicolon is only a very simple example. There are plenty of other ways to influence the structure of a statement. A common way to attack a select query is by injecting a union statement. The union statement tells the database server to execute both queries and combine the data into one dataset. This type of attack is well suited to steal data from the database. Another versatile attack is the insertion of a Boolean clause. For example, many queries filter the results in the where clause. By appending a Boolean clause that is always true, the attacker can disable filtering. Consequences are the leaking of information, but also bypassing authorization checks. Another way to modify the structure of the query is by injecting the comment symbol. When the database server encounters a comment symbol, everything after that is ignored. So, if the attacker injects the comment symbol, he can eliminate the trailing part of a query. The consequences can be severe, since additional constraints are often put at the end of a query. From these examples, it becomes clear that SQL injection comes in many shapes. And these were the easy ones. Tools like SQLmap collect a variety of potential attacks. They even support scanning applications for potential SQL vulnerabilities. These results from SQLmap paint a more complete picture on the complexity of SQL injection attacks. Back to the example scenario from before. This simple example suffices to illustrate the underlying cause of these vulnerabilities, a lack of context. The database server does not have enough information to determine which part of the query is data and which part is code. The next part covers proper defenses against SQL injection vulnerabilities.